moving on. So, what we're looking at here, right? We have some harder distributive property problems. We have some harder equations that we're going to look at here. So, let's take a look at some of these. Think about how we would solve these. Your first rule as you look at these is, again, simplify any parentheses. So on this first problem, you got to simplify this 2 times each term inside that set of parentheses to begin with. So we don't do anything with the negative 4d. Leave that alone. It has nothing to do with the parentheses, so we leave it alone. Then we do 2 times the first term, 2 times 3 is 6, and 2 times the second term, that's a positive 2d. All right? So from there, we have an equals negative 14. All right? Now, as we've talked about before, anytime you can combine like terms that are on the same side of an equation, do it. Well, we've got negative 4d and a positive 2d. Combine those to negative 2d. Plus 6 is equal to negative 14. At this time, you're down to a 2-step equation again. So anything being added or subtracted to the variable has to be moved first. So you're going to get rid of that 6. Add the opposite of 6, which is a negative 6, to both sides. Negative 6 and 6 is 0. What you have left is that negative 2d. On the other side, you got negative 14 minus 6, which is negative 20. Back down to a 1-step equation. So at this point, divide both sides by the coefficient in front of that d. Negative 2d and negative 2d, divide those, you get 1. 1d. And then negative 20 divided by negative 2 is 10. D is equal to 10 in this problem that we have here. Alright. So, another one. Same basic idea, but I wanted to show you this one because this is one that a lot of people have issues with. If you follow the rules, this is not an issue, but the big problem is everybody wants to take the negative 6 minus 3 and they want to combine those. That is not the first step in this problem. The first step in this problem, as we look at it, I'll even put a line down here so we can see the difference. As we look at this, first thing you have to do is take this negative 3 and multiply it by each term inside that set of parentheses. This negative 6 has nothing to do with that set of parentheses, so we're going to rewrite it. At this time, negative 3 times 2k is negative 6k. That's important to remember. That's a negative 3 there. A negative 3 times 4 is a negative 12. Guarantee you're going to see that on your test. Twice, if not 3 times. Alright, so now we're just down to a like terms problem. Like terms here. And if you
Sophia Lazama, if you're in the building, can you please report to the front office? Sophia Lazama to the front office. Thank you.
Again, if you need to put that line so you know the left and the right side, do so. But the only like terms you have right now are the negative 6 and the negative 12. And that gives you negative 18. You still have a negative 6k. Alright? And then that's all equal to 18. From here, you're down to a 2-step equation. So with this 2-step equation, what I want us to do, anything being added or subtracted to the variable, that's the negative 18. So we have to add 18 to both sides. 18 minus 18 is 0. So you get negative 6k is equal to 36. Down to a 1-step equation. So at this point, you're going to divide both sides by that coefficient in front of the x. Because negative 6 divided by negative 6 gives me a positive 1k. 36 divided by negative 6 is negative 6. So k is equal to negative 6. All right? Okay. Hopefully we're doing okay there. Here's the last set. Last set of difficult equations. As we look at this, what we have now is variables on both sides. When we talk about this in class, what we talk about is moving all your variables on the one side, all your numbers onto the other side. So as we look at this, some of you guys will benefit by putting that line down the middle. Right now, as you look at this, you have variables on both sides. It does not matter which side you move them to. For me, I would move them to the left side. When I look at this, I've got a negative 2k. To move it to the other side, you're going to make it 0 by adding the opposite. So you're going to add 2k to both sides. 2k and 6k gives you 8k. Then you have a minus 25. That's 0. Now it's equal to 7. What you have now is a nice little easy two-step equation. You need to get rid of the negative 25. So you're going to add 25 to both sides. 25 and negative 25 is 0. You have an 8k left over. So at this point, you're going to take 7 plus 25 to get 32. And now, to get k by itself, you're down to a one-step equation. Divide both sides by the coefficient in front of the k. So you're going to divide both sides by 8. 8 divided by 8 is 1. You get k, and then 32 divided by 8 is 4. Alright, so, last one. 5 times the quantity r plus 3 is equal to 2r. As we talked about before, just left and right side. When we look at these, no matter what problem we look at, you have to simplify parentheses first. So we have to do 5 times each term inside that set of parentheses. So 5 times r is 5r. 5 times 3 is 15. And on the other side, we just rewrite it. So now again, you have variables on both sides. You need to pick a side to move your variables to. I would pick the left side. So I take this 2r and add the opposite. So I'm going to add negative 2r to both sides. Negative 2r and 5r is 3r. Plus 15 is equal to 2r minus 2r is 0, so all you have left is just a 6. So now, what I would do is you got a two-step equation. Anything being added or subtracted to the variable r, you move first. So you're going to add the opposite of 15, which is a negative 15. Negative 15 plus 15 is 0. So all we have left is just this 3r. That's what goes down here. And 6 minus 15 is a negative 9. And just simplify this. Divide by the coefficient in front of r. Divide both sides by 3. R is equal to negative 3. Alright, ladies and gentlemen, those are some tougher problems dealing with solving equations. If you have any other questions about any of the other assignments or any of the problems that you do, come on in, talk to me, and I'll help you fix them. Alright, guys, have a good day. Bye.